Alright guys, today we're going to learn about naming ionic compounds with transition metals and also tin and lead. So in the last video we talked about what an ionic compound was. An ionic compound means there's a metal that forms a bond with a nonmetal. If you look at your periodic table, there's this staircase. The staircase is great because it separates the metals from the nonmetals. Everything below the staircase was a metal. Everything above that staircase is a nonmetal. So what an ionic bond is when you have a metal forming a bond with a nonmetal. So what's different about today is that now we're going to have a transition metal or tin and lead. So we're talking about this chunk of elements. There's the transition metals. And also tin and lead. Tin is Sn and lead is Pb. So we're going to talk about what happens when they form a bond with a nonmetal. Last video we talked last video was totally about groups 1 and 2, these metals, so the alkali and the alkaline earth metals, forming a bond with nonmetals. So today, how is it different? Well, here's how it's different. What was the charge of group 1, guys? +1. What's group 2? +2. We knew that, right? What's group 13? +3, plus or minus 4, -3, -2, -1, and 0. Well, what about the charge of transition metals? Do we know them for sure? We don't. And so that's how today's lesson is going to be a little different. We don't know the charge of transition metals. And we don't know the charge of tin and lead either. So we're going to talk about how we name them today. So a couple things I want you to have out. Your periodic table is a must. So have a periodic table out. Also have a polyatomic ion table, because we're going to talk about polyatomic ions again. Okay, and then also your chapter 5 guided notes. All right, let's get started. So it says to locate the transition metals in tin and lead on the periodic table. We just did that, so I think you know where they're at. Here's the deal with transition metals, tin and lead. They can have more than one possible charge. For example, iron can either have a +2 or +3 charge. It depends on who it's bound to, what its charge will be. So for transition metals, tin and lead, the charge will be written as Roman numerals. So we're going to represent its charge with a Roman numeral inside of parentheses. So when we write their charge in Roman numerals, this will communicate to people what the actual charge of the ion is. So if we need to put its charge as Roman numerals, let's review what Roman numerals are. Okay, I want you to write, this is not in your guided notes, but somewhere at the top of the page or the side of the margins, let's write this, okay, because you're going to have to know Roman numerals. If you wanted to write the Roman numeral for 1, what would it be? An I. Yeah, so that's 1. What is it for 2? Yeah, it's 2 I's. And 3? 3 I's. 4? Yeah, it's IV. Okay, and number 5? It's just a V. How I always remembered this going through school is if 5 is V, 1 before 5 is 4. So 1 before the 5 is equal to 4. The V is equal to 5. And so 6 is what? 6 is VI. So it's the 1 after 5. Well, what number is 1 after 5, though? That's 6. So anyway, that's how I remembered it. 7, what would it be? VII. Number 8? VIII. And 9's a little bit different. What is it? IX. Good. And then 10 means what? 10 is next, yeah. So again, 1 before 10 is 9, so that's easy for me to remember. Okay, what you're going to see for transition metals in tin and lead is that most of them will have charges between 1 and maybe 6. So definitely got to know how to write the Roman numerals from 1 to 6. But you also should know 7, 8, 9, and 10 as well. All right, so practice problem 21 says, for each of the following ions, write the correct name. Here's how they're different, because now we've got Cu. If you look on the periodic table, Cu is right here. Is it a transition metal? It is. Okay. So the way that you're going to name it is a little bit different. Cu, well, we know that's copper. You don't change its name, you just write copper. But if this one has a +1 charge, how do we tell people that this is copper +1? Well, we need parentheses, and the Roman numeral in here represents its charge. So the Roman numeral 1 tells people that it is copper +1. And a chemist would say this is copper 1. Number 2, how would we write the name for this one? Copper, parentheses, 2 in Roman numerals. The 2 in Roman numerals tells us that the charge of the copper ion is +2. You guys try 3 and 4 on your own. Fe is a transition metal, and it's located right here on the periodic table. So Fe, what element is it, guys? Iron. And if it's +2, how do I tell people that it's +2? Parentheses with the Roman numeral of 2 on the inside. Okay, iron 3, parentheses with 3 as Roman numeral in the parentheses. Okay, so pretty easy. That's just kind of a little change when we're naming transition metals. So we're going to do this for all of these guys. And also for tin and lead right there. So let's go through some practice problems and figure this out. Okay, it says write the formula for the following ionic compound. It says lead, IV, fluoride. Well, if you look at where lead is right here, it's Pb. We don't know its charge for sure, but actually we do because it told us right here, right? What does the Roman numeral tell us? It tells us its charge is what? What's IV? 4. So its charge is +4. So I want to see you guys write +4 above the name. What are we writing above fluoride? Well, fluoride is for fluorine. What charge does it have? -1. Okay, so we're going to put a -1 right there. Now remember that crisscross method. The 4 goes down there. The 1 crosses over and comes right here. What's the symbol for lead? Pb. What number goes by the Pb? A 1. Do I need to write it? Nope. In chemistry, a 1 is implied here. If you so we'll just leave it blank. And fluorine is F. And what number goes down by the F? 4. Okay, now every time you use the crisscross method, you should ask yourself, can I reduce it? Can I reduce a 1 and a 4? And the answer is no, because 1 is already as reduced as it can get. So that is lead 4 fluoride. It's PbF4. All right, let's go to practice problem number 23. I want you guys to try this one now. So if you're watching the video, please hit pause, try this one on your own, and once you have an answer, hit play and see if you got it right. Okay, let's see how we did. Manganese, if you find it on the periodic table, is right here. So again, it's a transition metal. We don't know its charge, but they did tell us that it was manganese 4, which tells us its charge is what? +4. Okay, so bromine is over here on the periodic table. Again, all the halogens are a -1 charge, so I'm going to put that above the name. Now we do the crisscross method. Okay, manganese is Mn. The 1 comes down. Do I ever bring the sign down, guys? Nope, just the number. So 1, I don't need to write it in chemistry, it's implied. Bromine is Br, and a 4 goes down by the bromine. I can't reduce it because a 1 is already as reduced as it can get, so that is my answer. Manganese 4 bromide is MnBr4. Right, practice problem 24. Okay, again, try it on your own. Once you have an answer, hit play and see if you did it right. Okay, let's see how you did. Tin, guys, if you find tin on the periodic table, it sits right here. It's Sn. It's one of those we don't know the charge for, but it did tell us that it was tin 4. That does tell us that its charge is plus 4. Now, sulfate. You can look at a long time on the periodic table and you're never going to find sulfate. Guys, is this sulfide or is this sulfur? If it was sulfur right here, this would be called sulfide, right? So it's not on the periodic table. That tells us it's a what? Polyatomic ion. Okay? So sulfate, if you look it up on your polyatomic ion chart, sulfate has a charge of -2. So if we do the crisscross method, tin is Sn, the 2 comes down here, and then sulfate, if you look on your polyatomic ion chart, is SO4. Okay? But because there's a number greater than 1 that we're moving down, if we put the 4 right here, that would be telling people how many oxygens would we have? 44. That's not true. Okay? So we need parentheses around polyatomic ions. And does the 4 go on the inside or the outside? The outside. Okay? So that 4 comes down to the outside of the parentheses. Remember, with polyatomic ions, always use parentheses. If the number is going to be greater than 1 out here, you need parentheses. Okay, now we use the crisscross method. Should ask yourself, can I reduce it? 2 and 4, can that be reduced? Now what about this 4? Do I ever change what's inside of the parentheses? No, we can't change polyatomic ions, but we can reduce the number that's on the outside. So that would, since they both are divisible by 2, it reduces to Sn parentheses SO4 and 2. So that's its reduced form. So that is tin 4 sulfate. Does that make sense? 25. Okay. Practice problem number 25. It's copper 2 carbonate. Copper is right here, guys. We don't know its charge, but it did tell us that its charge was 2. Okay, that tells us its charge is plus 2. Carbonate. Is that on the periodic table? It's not. So that tells us it's a polyatomic ion. If you look at your chart, what is the charge of carbonate? Isn't it a -2? Okay. Now we're going to do the crisscross method. Copper is Cu. What number comes here? A 2. And carbonate, because it's a polyatomic ion, and this number is greater than 1, I'm going to use parentheses. Carbonate is CO3. Again, we can't change anything in here. And this 2 comes down and is on the outside. Now, can I reduce this 2 and this 2? Sure. So that gets reduced to Cu, CO3. Okay, and you might be asking, why didn't I draw parentheses around this one? It's a polyatomic ion. But if the number is 1, do I need parentheses? Nope. And so you can just write it Cu, CO3. Let's try one more like this. Practice problem number 26. Again, try this one on your own. Once you have an answer, hit play again and see if you got it right. Okay, let's see how we did. Chromium sits right here on the periodic table, guys. It's right here. And it tells us that its charge is Vi. So Vi is what in Roman numerals?
6.
Plus 6. Yeah, that is a 6. So chromium has a charge of plus 6. Now phosphide. What element is that?
Phosphorus.
That's phosphorus. Sits right here. What charge does it have? minus 3. So I'm going to put the minus 3 right above the name. Now we crisscross it. That 6 goes down there. The 3 comes here. Chromium is Cr. The 3 comes here. Phosphide is phosphorus, so that's just a P. And the 6 comes down by it. Can I reduce that, guys? Sure can. So Cr, what? 1. Do I need to write it? Nope. And P, 2. Yeah, because they're both divisible by 3. If you divide both of them by 3, this becomes a 1, this becomes a 2. Okay, so that's chromium 6 phosphide. All right, very good. Okay, now let's switch gears a little bit and go. They're going to give us the formula, and I want you guys to come up with its name. Okay? So this is going to be a little bit different. What we were doing just barely was going from the name, and you wrote the formula. Well, now we're going to go from the formula to the name. It's a little tricky. This is where it gets a little bit complicated. So please pay attention, pay special attention right here, and we'll get this down. But remember, this is kind of the biggest point right here. That when you add up the total charges of ionic compounds, the total charge has to equal 0. Okay, so the total charge has got to equal 0 for neutral compounds. And I'll tell you what that means here in a second. We're going to work through a lot of examples. Stay with me. I promise if you pay attention, you'll catch on pretty quickly. Okay, practice problem number 27. It gives us the formula, and it wants you to come up with its name. Okay, except for there's one problem with this. See, what element is that? That's copper. Is it a transition metal? So do we know its charge? We don't know its charge. So when we write its name, it's going to be copper. But with transition metals, so all of these guys, and tin and lead, we're supposed to tell people its charge inside of parentheses. We're supposed to put its charge in Roman numerals right here, but I don't know its charge. So there's a little trick that we can use to figure out its charge. But let's just go ahead and name this one. What is Cl? Chlorine. How do I change its name? Yeah, we change it to chloride. So the only thing left is I've got to figure out the charge of the copper ion and put it in here in Roman numerals. Here's how we do this. Okay? So we can figure out, we don't know the charge of copper, but we can figure it out because we know that the total charges of this whole compound, the total charges have got to balance to 0. Do I know the charge of chlorine?
Yes.
Okay, chlorine is right here on the periodic table. It's a minus what? Minus 1. So what I always do is draw a line down, and I divide the metal from the non-metal. So it's like dividing the compound in half. This half is the cation, the metal cation. This side is the non-metal anion. Okay, we know that the charge of chlorine is minus 1. But how many chlorines do I have, guys? I've got 2. So what's a minus 1 times 2? That's a minus 2. Well, if this half of the compound is minus 2, and we know that the whole thing sums to 0, what does this half have to be? It has to be plus 2, right? With me? Okay, but when we name it, we're going to name it after the charge of one of these ions. So if I've only got one copper here, what does the charge have to be so that its total is plus 2? This has to be plus 2 because plus 2 times 1 is plus 2. So when you name it, it's named copper 2, but how do I show that in Roman numerals? II. Okay? So that compound here, CuCl2, is copper 2 chloride. A little bit tricky, right? But I've got a bunch of practice problems coming up. We're going to go through almost every example I can think of that you'll see. Practice problem 28. Okay, we've got FES. What is FE? That's iron. It sits right here. Okay, again, it's a transition metal. Do I know its charge? No. So when I write its name, we're going to put iron. But because it's a transition metal or tin or lead, we need parentheses telling people its charge. And then what is S, guys? Sulfur. How do I change its name? Good. Don't forget to change the suffix to IDE. So it's iron something sulfide. Now let's figure out what the charge of iron is. Can I look at the periodic table and say, oh, well, it's in this group, so it's plus something? Nope, because it's a transition metal. We don't know. But we can figure it out from the other side of the compound. So draw your little line right there. Sulfur sits right here. What is the charge of sulfur? -2. We know that one, right? So let's put a -2 right here, because that's what its charge is. How many sulfurs do I have? Just one. So what's a -2 times 1? It's a -2. Well, we know that the sum of these charges has got to balance to 0. So what does the other half have to be? +2. I've only got one iron atom, so what does the charge of it have to be? +2, because +2 times 1 is +2. So when you name it, how are you going to name it? Iron, in Roman numerals I need 2, which is 2 I's, sulfide. So iron 2 sulfide. Okay. All right, practice problem number 29. Okay, let's do this one together and then I'll let you do some of the other ones on your own. SN, what is it? It's tin. It sits right here. It's one of the ones we don't know for sure. Okay, so when I write its name, we're going to put tin. Because I don't know it, I need parentheses telling people its charge in Roman numerals. And what is I? Iodine, but how do I change its name? Iodide. Okay, so it's tin something iodide. Now let's figure out what goes in here, and we'll put its charge in Roman numerals. Okay, I don't know tin because it's one of those I don't know. Let's figure it out from the other side of the compound. What is the charge of iodine, which sits right here? -1. How many do I have? 4. So what's a -1 times 4? For a total charge of -4. Now we know that the total of this compound sums to 0. So if that half is -4, what does this have to be? +4. We've only got one tin, so its charge has to be what? +4, because +4 times 1 is +4. How do I write 4 in Roman numerals? IV. Okay. So that is tin 4 iodide. Okay, this is about as tricky as I could come up with. Let's see if you guys can do this one on your own first. Try it. Hit pause on your video right now. Try it on your own and see if you can get it right. Okay, let's see how you did. PB, guys, is lead. It sits right here. It's one of those that we don't know for sure. Okay, but when we name it, it's going to be lead. And because it's one of those ones we don't know, we need to tell people what its charge is inside parentheses in Roman numerals. And then what is N? Nitrogen. How do we change its name? Nitride. Good. So remember to change its name to IDE at the end. Now all we have to do is figure out the charge of lead. But when I look over here, I don't know what its charge is. So let's figure it out from the other side of the compound. What is the charge of N? Nitrogen. You can look at your periodic table and there should be a -3 above it, right? Okay, that tells us that the charge of one nitrogen is -3. But how many do I have? 4. So what's a -3 times 4? It's -12. If this sums to 0, which it does, if this side is -12, what does the other side have to be? Well, it has to be plus 12 because plus 12 minus 12 is equal to 0. But the tricky part about this problem is now we have more than just one lead atom here. I name it based off of the charge of one of them. So what times 3 is equal to plus 12? Let me say that again. What charge goes here times 3 is equal to plus 12? And it has to be plus 4. Because 4 times 3 is plus 12. So when I name it, you're always going to name it based off what goes here, the charge of one of the lead ions. So how do I write 4 in Roman numerals? IV. Okay. So that is lead 4 nitride. How many of you guys got it right? Just curious. Okay, good job. That's a tricky one. I mean, they don't come any more difficult than that one right there. All right, let's move on. Practice problem 31. Again, let's have you guys try it on your own. Hit pause if you're watching the video. Try it on your own and see if you can get this one right. Okay, let's see how we did. Fe is iron, and it sits right here on the periodic table. It's one of those ones we don't know the charge of. So when I name it, I need iron. Because it's a transition metal or tin or lead, I need its charge in Roman numerals inside these parentheses. And what is O, guys? Oxygen. How do I change its name? Oxide. Okay, now I can figure out what the charge of iron is by figuring out what the charge of the other half of this compound is. Oxygen sits right here. What's its charge? -2. But I've got 3 of them. So what's the total charge on this side? -6. All ionic compounds that are neutral have a sum to 0. Their charges are going to sum to 0. So if that side is -6, what does this side have to be? +6. Because that's the only way it can sum to 0. But I've got 2 iron atoms. So what does each one have to be? What times 2 is +6? Yeah, and it's got to be, so +3, right? 3 times 2 is +6. So when I name it, I'm going to name it based on what number comes here. How do I write 3 in Roman numeral? Yeah, 3 I's. Okay, so that's going to be called iron 3 oxide. Who got it right? Good job. Okay, we're getting it. I think we're catching on. Let's try a few more. This one has a little twist because, what do we call this guy, guys? Are you going to find that on the periodic table? No. So what is it? It's a polyatomic ion. So get your polyatomic ion chart out, and that will help you solve this one. Try it on your own. Hit play once you've got it. Okay, let's see how you did. Cu is copper, and it's found right here on the periodic table. It's a transition metal. So when we name it, we're going to put copper. And because it's a transition metal or tin or lead, we need to tell people what its charge is in Roman numerals. I don't know what its charge is yet. We'll be able to figure it out later. But let's name this other part. This is a polyatomic ion. So hopefully you have a polyatomic ion table. One is in your guided notes if you ever are doing these problems without it. Your guided notes has one in it. What is C2H3O2? It's called acetate. Do I change the name at all? Okay, so I just write acetate. Now, all I have to do is figure out what the charge of copper is. I can do that if I divide this compound into 2 halves. On this half, what is the charge of acetate? Well, it's a -1. How many acetates do I have? There's an implied 1 right here, so that's just 1. So what's a -1 times 1? Well, it's a -1. If I know that it sums to 0, what does this side have to be? It has to be +1, because +1 minus 1 is 0. I only have 1 copper atom here, so what does its charge have to be? +1, because +1 times 1 is +1. So when I name it, I'm just going to name it copper 1 acetate. Who got it right? Very good. Guys, I've got one last practice problem. Let's try it now. Practice problem number 33. It's actually got how many parts to it? 8 parts. I'm going to do the first 2 parts with you so I can kind of show you what you're supposed to do. And then I'll give you time to try the other 6 on your own. So here we go. If I give you the name spelled out, what are you supposed to do? Give you the formula. You're supposed to write down the formula. Okay? If I give you the formula, what are you supposed to write? Its name. Okay? That's kind of how this works. So let me go through the first 2 with you. Potassium nitrite. Okay? Potassium. What do I always write above the name, guys? It's charge. Well, let's find it on the periodic table. Potassium is right here. What charge does it have? +1. So I'm going to put a +1 above it. Always do it. Nitrite. Now, is this nitrogen? No. How do we know it's not nitrogen? If it was nitrogen, what would it be called? Nitride. It's not nitride, so we know that it's a polyatomic ion. It's one of those I hoped that you guys were going to memorize, right? So nitrite, what's its charge? Well, it's a -1. Now that I have the charges for both of them, what do? Crisscross. Potassium is K. Nitrite is NO2. Okay, this 1 has got to come to the outside of the parentheses. But if it's a 1, do I need parentheses? Nope. So that right there, KNO2, is the formula for potassium nitrite. Okay, good. Let's go to number 2. This one gives us a formula, and it wants you to write its name. What is Cu? Well, it's right here on the periodic table. It's called what? Copper. Now be careful. You should always ask yourself, is it a transition metal or tin or lead? Yeah, it is. It's a transition metal. So I need parentheses, and you need to put its charge in Roman numerals on the inside. What is F? Fluorine, but how do I change its name? Fluoride. Okay, so now it's all done except for I need its charge. How can I figure out its charge if I don't know it because it's a transition metal? Yeah, figure it out from the other side. Fluorine sits right here. What's its charge? -1. So I'm going to write a -1 here. But how many fluorines do I have? 2. So that's a -2. If this whole thing sums to 0, which it does, what does the other half have to be? +2. I've only got 1 copper atom, so what does its charge have to be? +2, because +2 times 1 is +2. So when you name it, in Roman numerals, copper 2 fluoride. Okay. I would like you guys to try 3, 4, 5, and 6. Oh, there's 2 more actually. So 7 and 8. So 3 through 8 on your own. I'm going to give you some time. If you're watching the video, please hit pause. Try them. See if you can get them right. Once you have an answer for each one of them, then hit play and we'll see if you got them right. Okay, let's see how we did with these. On number 3, we got magnesium sulfite. So let's first find magnesium. Magnesium is Mg. It's right here on the periodic table. Do we know its charge, guys? Yeah, we do. It's +2. All of the group 2 elements are +2. So I'm going to put a +2 above it. And sulfite. Now be careful with this one. A lot of students might think that it's sulfur. But if it was sulfur, it would be called sulfide. It would end in IDE. Because it ends in ITE, that tells us that it's a polyatomic ion. Sulfite has the charge, if you look on your polyatomic ion table, of -2. So I'm going to write -2 above it. Always, guys, if it gives you the name, write the charge above it and then crisscross it. Okay, so we're going to do the little crisscross method. Magnesium is Mg. And this 2 comes down by the Mg, so I'm going to bring it down. Again, don't bring down the sign, just the number. sulfite is polyatomic ion, so I can get its formula from that table, and it's SO3. So I'm going to put SO3. Now, if I've got a number greater than 1 coming down, I need that number to be on the outside of the parentheses. So let's put in parentheses here. And we're going to put that 2 on the outside of the parentheses. Okay, but then we use the crisscross formula, so you should always ask yourself, what question? Can you reduce it? Can you reduce this 2 and this 2? Which means, are they both divisible by the same number? Yeah, you can divide both of them by 2. So let's reduce it, and it becomes MgSO3. Okay, and you might be thinking, well, why don't I include the parentheses? Well, if the number out here is a 1, you don't have to put parentheses because it doesn't change anything. So that's a great problem. Magnesium sulfite is MgSO3. How many of you guys got that right? Good job. Okay, let's go to number 4, SRI2. First of all, let's start by finding SR on the periodic table and find out what its name is. SR is right here. It's called strontium. What charge does it have? +2. Let's look at where I is. I is iodine. It's right here. Has a -1 charge. So since it gave me the formula, we're supposed to write its name. So what is SR? Strontium. Now, be careful right here. Do I need parentheses and tell people what its charge is? On this one? I don't. How come? Everyone knows its charge is going to be +2. It's not a transition metal where it's a question mark. Okay, everyone knows strontium is +2. So I don't need to do that. We're just going to call it strontium. We don't change the name of the first one. The second one, though, iodine, how do we change its name? To iodide. Strontium iodide. That's all you do. Okay. Number 5, iron 2 phosphate. Again, when it gives you the name spelled out, what do I need to write above it? Its charge. Well, iron sits right here. Do I know its charge by looking at the periodic table? I don't. But did it tell us? It did. This Roman numeral tells us its charge is what? +2. Now, phosphate. Be careful with phosphate. A lot of students think that it's phosphorus. But if it was phosphorus, wouldn't it be called phosphide? So it's not phosphorus. Let's look it up on the periodic table. Phosphate, or look it up on the polyatomic ion table. Phosphate has a charge of -3. It's a polyatomic ion. So if we do the crisscross method now, iron is Fe. What number goes by the Fe? The 3. Phosphate, if you look up on the polyatomic ion table, its formula is PO4. But I've got to bring a 2 down, so I need parentheses. And that 2 goes on the outside of the parentheses. Can I reduce a 3 and a 2? And the answer is no. That's as reduced as it can get. So Fe parentheses PO4 parentheses 2 is iron 2 phosphate. That's a tough one. Who got it right? Good job. Okay, let's go to 6. Sn. First of all, let's find it on the periodic table. Sn is right here. It's tin. Is it one of those ones that I need to put the parentheses for? It is. Okay, so let's be aware of that. So let's write tin, parentheses, something. I don't know what it is yet. And then how do you change the name for oxygen? Oxide. Okay. Now, all I have to do is find the charge of tin, but because it sits right here, I don't know for sure. Let's figure it out from the other side of the compound. What's the charge of oxygen? -2. How many do I have? 2. So what's a -2 times 2? -4. Well, we know that the charges have got to sum to 0. So if this half is -4, what does this half have to be? +4. I've only got one tin atom here, So what does its charge have to be? It has to be plus 4 because plus 4 times 1 is plus 4. So when I name it, I'm naming it after the charge of one of the tin ions. So how do I write 4 in Roman numerals? IV. Okay. So that would be tin 4 oxide. Okay, a couple left. Sodium phosphide. Sodium, let's first find it on the periodic table. It sits right here. Okay, there's sodium. What's its charge? Plus 1. So I'm going to write that above it. It's plus 1. Phosphide. What element is that? That's phosphorus. Yeah, if we change phosphorus to IDE, isn't that phosphide? So phosphorus sits right here. What charge do these guys have? You should have a -3 written there because they form a -3 charge. Okay, so if we do the crisscross now, sodium is Na. What number goes by the Na, guys? 3. And phosphide is phosphorus, P. And what number goes by it? 1. Do I need to write it? Nope, it's implied in chemistry. A 1 is implied. So Na3P. Who got it right? Okay, very good. Last one, and then we're finished. Okay. FeBr2. Fe, let's first find it. It's iron. Do I know its charge? No, it's a transition metal. So when we name it, we're going to put iron, parentheses, and then what's Br? Br sits right here. It's bromine. And what charge does it have? -1. But how would I change its name? Bromine to what? Bromide. We change the suffix to IDE. Now we just have to figure out what the charge of iron is. I don't know it by looking at the periodic table, but I can figure it out by the other side of this compound. Bromine is -1. How many bromines do I have? 2. So the total charge is -2, right? That means the total charge over here is what? +2. I've only got 1, so it's got to be +2, because +2 times 1 is +2. To write it in Roman numerals, looks like that. Iron 2 bromide. Who got it right? Okay, guys, this was a great problem. It's a great mix. If you can do these 8 problems here, you should be able to do any problem I would put on a test, a quiz, or anything. Okay? So this is a great skill to learn. Again, we're naming ionic compounds. Let's review before I end the video. Ionic is what? Means what? One of them is a what? Metal, and the other one is a... So when they come together, you'll notice, guys, the first one listed is always the metal. The second one is the non-metal. So whenever they come together and form a bond, that's an ionic compound. There are certain rules to naming them, and we have learned them throughout the last 2 videos. So hopefully this helps you. To give you some more practice, in your student workbook, there's a couple of worksheets that I would like you to try. Okay? One of them is called Naming Binary Ionic Compounds Worksheet. So the Naming Binary Ionic Compounds Worksheet. And then there's also another one. It's called Naming Polyatomic Ions Worksheet. So head to your student workbook and try to get those worksheets done, and hopefully this helped you.
What page are you on?